Hello, this is Tucker from the Math and Physics Resource Center at SVSU, and in this video we're going to go over an example of an hypothesis test. So, let's just get into the example. A call center claims that at least 85% of its callers are left satisfied with the help they received. A random survey of 100 customers showed that 72 of the respondents were satisfied after calling. Is there evidence to support the call center's claim of 85% satisfaction? Use alpha equals 0.05, with alpha being that little symbol. So, when we see a problem like this, we have to determine what kind of test we're going to be using. In this case, since we're dealing with a percentage or a proportion, we're going to be doing a 1 proportion z-test. So from here, what I like to do is just pull out all of the relevant information, which generally is just the numbers. So here we've got a call center claiming that 85% of its callers are left satisfied. So we can assume that that is the population proportion. So our P will be 0.85 in this case, which leaves our Q, which is 1 minus P, to be 0.15. Now it says a random survey of 100 customers, which means our sample size, N, is 100, showed that 72 of the respondents were satisfied. So we'll take that number of successes and divide by the sample size to get our P hat, or our sample proportion. So 72, that's a 2, over 100 equals 0.72. And now it also tells us that alpha is 0.05. Lastly, we need the standard deviation, which in this case we'll do by having P times Q all over the square root of N. So if we plug in what we know, we have 0.85 times 0.15 all over the square root of 100, which works out to be 0.03571. Okay, so now that we have all the pieces that we need, there's one more step that we have to do before we can actually go on with the test, and that is checking all the conditions. So the first condition for this kind of test is that the sample is randomly selected, which you can generally gather from the question itself. So here we've got a random survey of 100 customers. So we have some smaller part of the population that was randomly selected for the survey, which clears that condition. And now the sample is sufficiently large, or the sample is big enough, which is super vague, but there is actually a definition for that. So in this case, sufficiently large or big enough means N times P is at least 10. That's a 1. 10. So to check this, we'll just take our N and our P and just multiply them to each other. So 100 times 0.85 equals 85, which is definitely greater than or equal to 10. So this is also checked off. And now we can continue with the test. So the first step of the test is going to be to set up our hypotheses. So our null hypothesis and our claim. So our null hypothesis is the kind of baseline that we're going to compare our claim to. So in this case, since we're trying to see if the 85% call center claim is accurate or not, this is the baseline that we're comparing to. So we're trying to see if our P, the population proportion, is at least 0.85. So now we need our claim. So we're trying to see if it's inaccurate that the call center is saying that 85% or more are satisfied. So in order to say that's inaccurate, P would have to be less than 0.85. So these are our two hypotheses for this question. Now, you might be wondering about this alpha value, what that really means. I'll go over that real quick here. So since we're dealing with like a normal curve, I know I kind of flattened that one. We need an area of 0.05 over here. And since our claim is dealing with less than, it's a left-tailed test, so we're going to be over here. So this area that I have shaded is 0.05 of the area of the entire curve. So 5% of all samples, if we have a randomly selected sample and we're assuming that our null is true, 5% of all of those random samples should end up in this area. Now, since our alpha is 0.05, any sample that shows up in this area, we're going to reject the null, which means that we're saying that it's inaccurate, basically. So in order to see if our sample's in that range, what I do first is figure out what z value corresponds to this alpha, or z alpha. So to do that, since we already have the area to the left here as 0.05, we can take this and go to the table to find our z. So if we find 0.05 here, shows up right in between these two at -1.6, and then it's between -1.64 and -1.65. So we'll call our z alpha -1.645, which is just in between those two. So now that we have our z alpha, we have to find if our sample is less than this z alpha in order to reject our null hypothesis. So let's figure out what our z value is. Remember that our z is going to be p hat minus rp all over the standard deviation, which with the numbers that we have is going to be 0.72 minus 0.85 all over the standard deviation 0.03571. So this ends up giving us -0.13 over the standard deviation, and I calculated that out to be about -3.64. So our z alpha, remember, was -1.645, and we're going to compare these two z values now. So since it's a left-tailed test, we're looking for this z value to be less than the z alpha, which it is. So that means that we can reject our null hypothesis, h sub 0. Now, what does that actually mean? That does not mean that our claim is necessarily true. It just means that the null hypothesis is false. I know that's kind of confusing, but just remember not to say that our claim is true. We can never prove that with just a test here. So, since we rejected the null, we can say that there is sufficient evidence to say that the call center's claim of 85% is inaccurate. Reject H0. Okay, so you might not have liked the Z stuff, but there's also one other way that we can solve out for this test. So we can take this alpha value, and we will actually have to find the Z for the sample anyway. So we can take the alpha, which is 0.05, and the Z, which we found to be -3.64. So what we can do with this, since it's a left-tailed test, this 0.05, if we want to reject, we need our p-value, or the area to the left of our Z, to be less than that 0.05. So if we want to find our p-value, we'll take this Z, the -3.64, and go to the table. So we got negative 3.64, which ends up being 0.00014. So our P, 0.00014, which is definitely less than 0.05. So once again, just reject the null. And you'd write a similar claim here. And that'll be your final answer. Sorry. That's about it. Thank you for watching.